For developing Java-based applications, you require JDK, and for running Java-based applications, JRE is needed. These two are totally different. JDK, when you develop applications, you require JDK, but when you want to execute applications, you need to have JRE installed in your system. Okay, so while developing, you require JDK, and while executing your applications, JRE is required. As a developer, you require JDK. Along with that, you need to have some kind of IDE, that is Integrated Development Environment. You might have seen many such IDEs. So here in the Java also, you can use either Eclipse or NetBeans. Okay, so NetBeans is one. Then similarly, IntelliJ. You have so many different IDEs. Eclipse is open source IDE, you can use. NetBeans is also open source, but IntelliJ has to be, for that we need to pay. Okay, so mostly people use Eclipse. With the help of Eclipse, you can actually develop Java-based applications. So Java means, as far as Java is concerned, you can develop different types of applications. Say it may be a simple console application or command line application. It can be a simple console application or command line application. That means from prompt you can be executing, whether it is Windows or Linux or Unix, whatever it may be. From command prompt you can execute. Similarly, you can develop GUI applications. So this is nothing but Windows Forms applications you can develop using Java. Then other part is actually web applications. You can develop web applications. Similarly, JMS, using that messaging systems you can develop, something like WhatsApp. Kind of applications also you can develop with the help of Java. So in general, using J2EE, Java to enterprise applications, you can build Java beans, you can develop web applications, websites, web services, message services, all those you can develop with the help of J2EE. And further, you can even develop mobile applications. You can even develop mobile applications with the help of the Java. So Java has actually 3 editions. J2SE, which is nothing but standard edition. So J2EE Enterprise Edition and J2ME is Micro or Mobile Edition. So like this, you have 3 different editions as far as Java is concerned. This Android actually was built from the J2ME. So with J2ME only, they built Android. So using Android, you can develop mobile applications these days. But the Android is not going to stop with mobile applications in the future. In number of areas, you are going to use Android. For example, take car. In the cars also, the OS they are going to use, that is nothing but, again, car OS we say. Dashboard OS or car OS we are going to use in the future. So that is going to be, say, Android. Android will be available on those things, and apart from cars and mobile phones, in many, micro devices or in our personal devices, we can use in the future. All of they are nothing but, the Android is nothing but, that's nothing but incarnation of Java. Another version of Java is Android. So using Java, virtually you can develop any kind of applications. Whatever type of application you want to develop, you can develop using Java. And another advantage of Java is write once, run number of times. So wherever you want to execute, you can execute. So that is because of Java's portability. Java, we know that it's portable. Portable in the sense, in Windows platform, you may develop Java application, then you can port it into Linux or Unix. So this is basically called as portability. So, and in Windows platform, you develop Java application. Then if you want to execute that on the Linux or Unix, you can execute, provided that there is actually runtime environment in the target OS. In the target OS, JRE is needed, then you can execute Java applications. So that is what we say as Java is portable. Java applications, whatever you write, are going to be portable. But remember, whatever application you develop, that can be portable. But whatever J2SE you have, J2SE or JRE, they are not portable. For Windows, you have one JRE. For Linux, you have another JRE. For say Unix, you have different JRE. So JRE is very much machine dependent, whereas whatever applications you develop, they are going to be machine independent. So it's because of actually Java's bytecode file. Whenever you write any code in the Java, when you compile, you get there a bytecode file. So bytecode file is neither source code nor straight away executable code. It is in intermediary format. So Java runtime environment is going to execute that bytecode file. Basically, Java is a compiler as well as interpreter. Whenever you write code, whenever you want to compile, at the time it works as a compiler. But whenever you want to execute, at the time it's going to be working as a interpreter. So very first thing is Java is portable, Java is a compiler, Java is actually interpreter. So interpreter in the sense, in the runtime environment, whatever application you develop and whatever application you develop, that gets converted to bytecode file. So that bytecode file will be interpreted in the runtime environment. So that's why we call it as Java a interpreter. So it's both compiler as well as interpreter. And one more is network centric. Using Java, you can develop network based applications. It need not be just standalone application. Okay, so that means it's not going to run in a single computer. It can be a network centric application. You can develop network centric application. Similarly, Java is very simple. When you look at Java language, actually, you have very high level constructs. So with the help of that construct can produce equivalent statements in the C. For example, you take a simple construct that may be equal to 4 or 5 C language constructs. So like that, Java is going to be very, very simple. Okay. And one more thing, Java is very simple. Even data types also, when you look at Java, they are very simple. If you compare with C language, in the C you have a lot of confusion, like signed integer, unsigned integer, so signed character, unsigned character. You don't have any such thing. Java types are very, very simple. Primitive types are very simple. And Java supports 2 different types of data. One is actually, say, primitive data, or by default it is primitive data, and other one is going to be, say, reference data. So in the case of primitive data like int, float, so they can be called as basically primitive, whereas whatever classes you develop, they can be reference type of data. So primitive types of data, they use stack area, and reference types of data, they are going to use heap area. So that way Java is simple, and Java is secure, Java is robust, and Java is object oriented. So with the help of these buzzwords, basically you can describe Java. So Java very first version got introduced in 1995 by James Gosling. So he is the main person actually who developed it. Initially Java was called as Oak, because opposite to the James Gosling office, there was an oak tree. By looking at that tree, he developed Java. So because of that, he named it as Oak language initially, but later on they changed it to Java. So there is a meaning even for Java. It's nothing but liquid. So Java applications can fit anywhere. Like liquids can take the shape of the container. Java applications can serve you whatever type of requirement you have. That means it can fit anywhere. So that's the reason they named it as Java language. To work with Java, as I told you, you require JDK and JRE. So along with JDK, you need to have Eclipse, IDE, interactive development environment, or it may be NetBeans, or it may be IntelliJ. So whatever you would like to choose, you can choose, but Eclipse and NetBeans, they are actually free. You can download them and you can use. And in the target machine, definitely you need to have JRE. Without JRE, you cannot be running Java applications. So these are the prerequisites for the Java language. Alamgir, are you following?
Yeah, of course. Yeah, no, these are very valuable information. Thank you. No, I'm following. It's great. Thank you.
And another thing is, Java is actually a case-sensitive language. It does differentiate between uppercase and lowercase. You might have worked with PLSQL. So when you work with PLSQL, I think you have some exposure to PLSQL. Do you have?
Yeah.
Alamgir?
Yeah.
Okay.
I have even some Java also. You know.
Okay. So in the if you look at PLSQL, it does not bother about the case.
Yeah.
That means uppercase or lowercase, it does not care, it does not bother. But as far as Java is concerned, it cares. So Java is what? Case sensitive language. It does differentiate between uppercase and lowercase. Okay. Then simply, see with Java you can describe like this. Java is first of all case sensitive. So I can say this as case sensitive. It does differentiate between uppercase and lowercase. Then similarly, Java is strongly typed. Okay. So one more thing is strictly typed. These two, strictly typed also we say it. It's both strongly typed as well as strictly typed language. So Java is what? Strongly typed. That means without declaring a variable you can't use. For example, you may write a equal to some 10. Later on you may write int a. In few languages this is supported. Something like basic language. This is called as here forward referencing. First you use variable, then after that you initialize. Even in JavaScript, this kind of mechanism we can use. This is called as actually hoisting. Hoisting JavaScript variables. Like that we say in the JavaScript. JavaScript and Java both are different. JavaScript we use only in web pages. Java we can use in the case of web applications only in the server side, not in the client side. So just I am comparing. Why I am comparing that is what is exactly strong typing and loose typing. For example, in the Java you cannot write like this. A equal to 10, int a you can't do. But in the JavaScript, first you can use variable, then after that you can use it. So it is not strongly typed in that case. That can be called as loosely typed language. Or if you look at VB, Visual Basic, that is another language. Even in the Visual Basic, such feature you have. Even in the basic language you have such feature. So without declaring variable, you can use. So whenever you assign a value to a particular identifier, at that time itself the type may be inferred. So they are more and more dynamic in that case. But Java is not that dynamic language. You can have some dynamism in this, but as far as typing is concerned, it's very strongly typed language. So without declaring variable, you can't use as far as Java is concerned. So when I correct it, it's going to be something like this. Int a, then followed by a equal to 10 when I write, this can compile successfully. So in the other way if I write a equal to 10 followed by int a if I write, it does not accept. So this is what it is actually strong typing we can say. Then similarly, one more I do like this. CH K I may declare or CH, okay, K, sorry, CHAR, some K I write like this. If I try to assign K equal to some 65, it does not accept. Reason, the char CHAR I have taken, K is what type of data? Character type of data, I am assigning 65. In the C language, this is accepted because when I assign like this 65, it's going to be treating it as character A. Because in the ASCII characters, A is equal to 65. So automatically, it can assign a value A as far as C is concerned. But in Java, this is going to be offending us, it's an error. It cannot compile in such cases. So that's why we call it as a strictly typed language. Typing is very, very strict as far as Java is concerned. In Java, it's very strictly typed language. Java is both strongly typed as well as strictly typed language. Okay. Similarly, whenever you look at any language, the language is basically has certain tokens, just like English language. In English, we have parts of speech like verbs, adverbs, noun, pronoun. So with the help of that only, you form a sentence. So in the Java also same thing, we have set of tokens. Using those tokens only, you can write statements. It's not only the Java language, you can take any language, any computer language, they have the tokens. So the tokens are basically like this. First what we say, keyword. A keyword is a reserved word for its intended purpose, you must use it. For example, I have written int a. So when I write int a, int is a keyword, a is an identifier. So int is predefined one. To declare integer type of data, I use int, and a is what here? It's an identifier. So identifier is nothing but user invented word. I invented that because it's a variable I have invented. So keywords are nothing but reserved words. Even this int you can compare with our English language. For example, you take English, in that you may use is, was, have, has. They are nothing but actually predefined verbs. So for their intended purpose you must use. For whatever purpose if you want to use, probably the reader, whatever you write in English, the reader may be getting confused with that. So same thing may happen in the case of computer. So if you try to write something like this, here if I write int float, this can be an error. Reason, int is a keyword and float is a keyword. Float keyword I cannot use as an identifier. So in such cases, compiler will give an error. So one of the tokens is what here? Keywords. Then other thing is identifiers. Then followed by here operators. Then other thing is here separators. So these are basically the tokens. With the help of them you can be forming statements or sentences. You can make a statement with the help of these things. For example, if I write here int a equal to 10. So this is a full sentence or full statement I can say. Here I have a keyword, then I have an identifier here, then followed by I have an operator, and I am having a constant here, then followed by a semicolon. So like this, it is using all the tokens. In this you have a keyword, you have an identifier, you have actually an assignment operator, then followed by you have a number, that's nothing but constant, then is a literal, then followed by you have a semicolon. It's using here all the tokens. Keywords are in, keyword is in that, there is an identifier, there is an operator, with the separator. So like this, you can have the tokens. With the help of that, you normally write the statements in a Java program. So in a Java program, you are going to be doing in that way. Okay. So these 4 tokens, with the help of that, you are going to be writing the program. Then other point is actually, whenever you talk about any program, the program contains data as well as instructions. So the program requires both the things. The data is required, set of instructions is required. So instructions, they are going to act on the data. So why we use instructions? To process the data. So therefore, when you look at any program, you require data in that, and you require other thing is what? Statements or instructions. They are going to work on the given data. A program is nothing but combination of both data and instructions. Program equal to, it's nothing but data plus instructions. So instructions, they are going to work on the data, they process the data, and ultimately they give you the result. So together, this is called as basically a program. How big it may be or how small it may be. Instructions. Okay, the spelling is wrong. So how big the program it may be or how small it may be, there should be data and there should be instructions. So that we normally call as a program. Program is basically set of statements at one time we write in a file or set of files, and once we complete it, we are going to compile. So with compilation, what happens? You convert all this code into bytecode file, then later on you can execute that bytecode file in the runtime environment. So program is going to be nothing but data plus instructions, and this data may be scattered among number of classes, number of files, and instructions also can be scattered into number of files and number of classes. And as far as Java is concerned, since Java is totally object oriented, everything you need to write in a class only. You need to write everything in a class. The methods you have to write in class, the variables you declare inside a class. So program unit is going to be a class as far as Java is concerned. So everything you are going to write in a class. But in C language, what happens? You are going to write everything in functions. In the functions you write code, then one by one you can execute. But as far as Java is concerned, all the code you must be writing in the class only. So through class only, you need to execute everything. And second point, Java has actually 2 types of data. Alamkir, you have any question?
No, it's great. Yeah, I'm really liking your direction.
If you look at actually the types of data, there are basically 2 types. One is primitive. So other one is actually primitive or default, I can say, default data types, and other one is going to be here reference type of data. When you look at primitive, so this is spelling actually, I think one thing and I type something, so due to the spelling mistakes. This is primitive we have, and other one is what? Reference type of data. When you look at primitive, these are the types you have in that. When you look at primitives in this, these types of data available for us. You have a char, then you have actually byte type of data, then you have short integer, then other one is here, we have a int, then long we have followed by, we have a float and double. So these are the types of data. We have float, double, then other one is here boolean. So using them, we can represent primitive data. So that's basic data we can represent with the help of these types. In Java, a char is 2 bytes. When you look at char, this is basically 2 bytes. It's going to be using 2 bytes. In contrast to C. In the C, it's only 1 byte. In C, just 1 byte. But as far as Java is concerned, it uses 2 bytes. See, when you look at C, it is 1 byte because in the C language, you can represent only ASCII data. As far as character data is concerned, you have here, one is ASCII, the other one is Unicode. I think you are well aware of this Unicode and ASCII. So in the case of ASCII, you can represent 0 to 255 characters. But when you look at Unicode, it's going to be 0 to 65,535. This many characters you have. Even in the Oracle, you may be declaring some varchar and varchar. So in the case of varchar, it can take only ASCII data, but when you go with nvarchar, it's going to be using, Unicode data. So varchar basically for English or English-like languages, whereas nvarchar can support any type of language. So in the Java, the character is going to use 2 bytes. All the characters are here Unicode characters. So what is the necessity? Char normally supports only English or English-like languages. But these days, we have a concept called as globalization and localization. These two concepts, the world is actually experiencing these two concepts very much. One is globalization, other one is globalization. We want to get connected globally, yet we want to be local. So like this, these days, our idea is, we want to be global, at the same time, we want to be local also. So therefore, in order to support such things, we require Unicode characters. It can be in English, it can be in Hindi, Telugu, like that. So that way, Unicode is going to be helping. But if you look at only ASCII, it can support only ASCII characters. That is from 0 to 255 characters only. It can support only English or English-like languages, like Hindi or Hindi-like languages. For example, you take Hindi, Bengali, Gujarati, then Marathi. Probably these can be Hindi-like languages. So in the same case, when you talk about English, that may be Russian language or say French or German. So these can be English-like languages. Set of alphabets are going to be same, but only the way you write is going to be differing. Some grammar may change and some words may change. Otherwise, alphabets are going to be same. So therefore, using ASCII, we can support only English or English-like languages. But if you want to do something with the Japanese, Chinese, Korean, it's nothing but CJK we say. It's Unicode, it's actually, it's top to down we write, ideographic characters. Similarly, sometimes you have to deal with Arabic languages, from right to left you write, or you may be writing many Indian languages. So in such cases, definitely ASCII does not help, does not work. So in such cases, Unicode can be very much useful. So therefore, in Java they made it as 2 bytes. So using 2 bytes, almost all the languages of the world can be now represented. So that's why they have taken it as 2 bytes. And char can support only 0 to 255. It cannot support negative values. But in C language, it supports negative values. But as far as Java is concerned, it can't support any negative value. So it can support 0 to 65,535. Similarly, in the integers, you have byte type of data. So byte means just 1 byte of data. But in the Java, you don't have anything like signed or unsigned. All are signed. If you look at byte, it uses 1 byte of data. Just 1 byte it takes. The range for this is going to be -128 to 127. So this many numbers are supported as far as byte is concerned. In a byte variable, you can put any value from -128 to 127. So when you look at short, this requires actually 2 bytes of space, and here -32,768 to 32,767. So like this is a range we can have for the short integer. Similarly, int. So in the case of int, it's going to be 4 bytes, and the range for this is -2,147,384,000. After that, I cannot remember exactly, xxx plus -1, 2, it's going to be like -2,147,384,000, then followed by here xxx. This is the range actually for the integer type of data. Then in the case of long, one more type of data we have, it's called as long. This can use actually 8 bytes. So this way we have integral types of data, and these are called as actually fixed numbers, or we can say absolute. It's called as absolute data. Now one more type of data is approximate data. It's nothing but float and double. You have these two things. Float requires 4 bytes, whereas double requires actually 8 bytes. So these represent floating point data. So when you look at float, this supports up to 6 digits after precision. Suppose you write 10 by 3. If you try to assign 10 by 3 a float type of data, it can support up to 3.333 up to 6 digits only. You have precision. After that, you don't have the precision. Same if you try to use the double, it can be up to 15 digits. So this is the difference between the float and double. Float uses 4 bytes and double uses actually 8 bytes. And one more type of data, what we have is Boolean type of data we have. So using Boolean, you can represent true or false values. Either true value or false value, you can represent with the help of the, say, Boolean type of data. So this is basically the data types which are primitives or which are default available within the Java language. Apart from this, you have other types of data that is called as object data or it is reference data. Reference data, we say it, either object data or reference data. So reference data is similar to pointers in the C language. How we manage pointers in the C in the same manner, it's getting referenced, but here you have type safety. Simply whatever type of data you want to assign to pointer in the C, you can assign whatever type of data you want to assign to pointer in the C, you can assign. But in the Java, if you declare reference type of variable, only that type of data you need to assign to that. Other data types can't be assigned as far as reference type of data is concerned. So these are similar to pointers in the case of C language. So these are basically data types, and using classes and interfaces, you can be creating